Hello, you guys. Okay, so today we're going to be doing Boyles and Charles test, the test review. So basically, I have several questions in here, but not all the questions are going to be on the test. I only picked a couple of them. So you're welcome to fill in the test review, and then from there you just go based on this review and try to help you with your exam for this online learning. So, anyways, on the calculations though, it's the same problem. The only thing is I changed one of the numbers, so it's the same strategy. Everything's the same. You just have to change the number and calculate it, recalculate. Okay. So, anyways, let's get started. Okay. So Boyles and Charles law test review, right? The relationship in which two variables, that means the independent and dependent variable, are compared in Boyles law, that would be your volume and pressure. Okay, and the independent variable, it's either the volume or the pressure, is the one that you manipulate, the one that you change. In Boyle's law, that will be the one that you change will be your volume. And the dependent variable for Boyle's law would be the pressure. So it really depends on how much you change the volume, and so that's what the pressure is really dependent on the volume. What must stay constant? So the only thing that would be changing, through experimentation or basically calculations, will be only the volume and the pressure. There are two things that needs to stay the same. Okay, and that would be the number of molecules, or the number of moles. That means the number of molecules are in the gas molecules, basically. Okay, and also the temperature needs to stay the same. Okay, so what type of relationship is Boyle's law? Boyle's law has an inverse relationship. And I mean by that is if you increase the volume, then the pressure will decrease. If you decrease the volume, then the pressure will increase. It has opposites. It's like opposite or reverse relationship. That's one way you could remember it. Okay, so basically this is Boyle's law. Now we're going to look at Charles' law. The relation of which two variables are compared in Charles' law, that will be temperature and volume. Okay, so what is the independent variable of Charles' law? That's when you change. That was I don't know if you guys remember the FET lab, but that was a bucket when you would increase the temperature. That will be your temperature. And then what is the dependent variable? That will be your volume. So it really depends. The volume depends on how much temperature you increase or decrease. Okay. And then what must stay constant in Charles' law? That's the number of molecules of gas. For sure. Number of molecules or moles. And of course, you have to keep the pressure. You try to keep the pressure constant. What type of relationship is Charles' law? That is a direct relationship. In other words, when you increase the temperature, the volume increases. If the temperature decreases, that means the volume decreases. So that's a direct relationship. Okay, so now let's get to the calculation. So again, don't get scared with the calculations. It's really the same way how I'm going to teach it right now. Really, it's just the same way. Okay, the only difference is that some one number change. I change one or two numbers. Okay, so like it would be the same problem except I changed the 32.5. Okay, so for this equation, this is what is the new volume. You're looking at liters, and that's the volume, and we're looking at pressure. So we're looking at Boyle's law, and Boyle's law pretty much the calculation is pretty much pressure, the initial, that we'll call it one, times the volume, the initial, equals the final pressure, which we'll call it 2, and the final volume, which we call it 2. So this is multiplying, okay? This is multiplying. Okay, so now what we need to do is we need to identify each one as the initial or final, either pressure or volume. So in here, if 32.5 liters of nitrogen at 748 milligrams of mercury are compressed. So this should be your initial. Okay, so since this is liters, and liters should be volume. Okay, so that means 32.5 liters equal, that would be your volume 1. Now this is initial because that's how it starts, and then what they do is they compress it. Okay, so this one is mercury, millimeters of mercury. That means that's the pressure. Okay, and that is still because it's this amount has this much pressure at the beginning. So it will be P1 will be 748 millimeters of mercury. Okay, now they compress it. They press it in to 725 millimeters of mercury. Okay, so it will be that's your pressure 2. So it would be 725 millimeters of mercury, and that will be your pressure 2. So what is a new volume? So they want to know the V2. They want to know how much is that. Okay, so the next thing we do is we plug it in the equation. We plug it in. So when we plug it in, we start with P1. It will be, now since we're multiplying, we're going to go ahead and put parentheses, 748. And then we're going to multiply by the initial volume, which is 32.5. 32.5, and that will be liters. And then that will be equal to your the P2, which is 725. And then times the V2. We don't know that one. Okay, now we got to move the 725. So you'll probably see this on your test. Okay, so we need to divide to 725 of mercury, millimeters of mercury, and then you do the same thing to the other side. So this is something you will see in your test, the setup for this. Okay, so that should be set up just like how you see it right here, except you're going to have a different number here. Okay, now we're going to go ahead and calculate it. Now we know that this is just 1, so really we just cancel it. So this will be at the end, volume will equal to, it should be, let me see, let me calculate. Okay, so once I calculate, now keep in mind, you're going to multiply the top first, and then you're going to divide it. Okay, and my answer is going to be 33.5. So you do have a calculator in your problems. So you're just going to calculate it on your own. Okay, so again, you just have to multiply this top part and then you divide it by 725. Okay, and that should give you your answer, okay, of what V2 is. Okay, so now let's look at the next problem. A gas with a volume of 5.0 liters at a pressure of 205 kilopascal. Now, kilopascal is another unit for pressure. Okay, so it says pressure of. So use those little clues to clue you in which is your pressure. Now, it's a gas that started with this initial volume. Okay, so this will be your V, your initial. That will be your P1, and then it's allowed to expand. So this is afterwards. It's allowed to expand to a volume of 12.0 liters. That will be your V2. So now they're asking for that pressure in V2. So that's why your P2 is unknown. So V1 would be 5.0 liters. Your P1 would be 205 kilopascals. And then your V2 should be 12.0 liters. So it's the same way. It's just very, very similar to your it's very, very similar to your exam, except I just changed the number. Okay, so let's go ahead and get started now. Let's go ahead and plug them in. So P1 will be 205 kilopascals. And I'm going to put parentheses because this is multiplying. And then V1 will be 5.0 liters. And that equals to your P2. And then your V2 is 12.0 liters. Okay, so so now we need to move that 12.0. So how do we do that? Why do we have to do that? Because we need to solve for P2. So we need P2 all by itself next to the equal sign. There can't be no number. So this number, you need to move it with the other numbers. And how do you do that? You look at the math. Look at the math. There's multiplication, and the opposite of multiplication is division. So you have to divide the number to itself. So you divide it by 12.0 liters, and then you do the same thing to the other side. And then, of course, this should be your setup, except one of the numbers or two are going to be different from your exam. Okay, so just make sure you match them up correctly. Okay, so anyways, so once that is done, you cancel that, and P2 is by itself. You see, you want it by itself. Anyways, if you think about it, 12 over 12 is just 1 anyways, okay? So now we're going to multiply these two and divide it by 12. When you multiply these two, it should give you 1025 kilopascals times liters, okay? So if you're wondering about the units, it really is just multiplying, and they're just, they just get carried over. And then that will be 12.0 liters. And of course, liters cancel each other out, and then P2 will be equal to 85.4 kilopascals. So that would be your answer for number 12. Okay. So again, be careful on the answers because remember, you have to calculate it. Okay, yes, I gave you the setup. I practically gave you all the answer. All you have to do is make sure you do the right numbers, and then you calculate it. Okay, it's really simple math, you guys. Okay, also it's just multiplying and then dividing. Okay, so let's go to number 13. So basically in here, you just cross multiply. So that would mean that V1 times the T2. Okay, now in here what we're dealing with, we are no longer dealing with Boyle's law. We are dealing with Charles' law, and they have a direct relationship. When it's a direct relationship, it's really the division. Okay, equals a division. Okay, so we want to make it easier for us, and by making it easier is by setting up this way. Okay, and by doing it that way, we have to cross multiply. So that means we got to reset our equation to V1 times, because we got to cross multiply to T2. It will equal to V2, and I'm going to put parentheses, times T1. Okay. So now we are ready, at least, we are ready to at least set up what is going on in here. So given a gas with an initial volume, so right off the bat, initial volume is 2.0 liters, and a temperature of this volume has this temperature, so that means it's T1, so that's 290 Kelvin. And then what is the final volume? So that is my V2, so that's an unknown. And then of course this unknown has T2 has 273 kelvins. So now the next thing we need to do is set it up. So V1 would be 2.0 liters, T2 would be 273 Kelvin, equals to V2, which is, we don't know. We don't know that one. Okay, and then T1 is 290 K. Okay, so in here, what we need to do is we need to move the 290K. Now, on your test, it did a little different, but I'm going to show you the answer for it anyways. So, but in here, I just get, it's going to be the same thing, except, of course, with the difference of the number, you know, it will make a different calculation in here. But the same way how to move them around is the same way, and it should give you the same answer. So in here, it would be 290 Kelvin, okay? And then you do the same thing to the other side, right? Why? Because remember, you want to move that 290 with the other numbers, okay? You want to have that symbol right here because you're solving for that. You want it by itself, okay? So it should give you, that should cancel, and it should give you a V2 equals, and then of course you multiply the top part, which in your test it should have the same thing. It should be 2.0 times 273, okay? And I believe yours has 3.0, right? So it would be 3.0 273 and then divided by 290K, okay? So in here it should be equal to, it should be, okay, so now I multiply these two. I got 546, and then 290 is on the bottom, and that should equal to 1.88. Okay, and that's liters because it's volume. Okay, now keep in mind on your test, it's gonna be, it's just the way it was turned around. So I don't know, I'm gonna change it to just like mine if I have a chance. But if I don't, really, it should be like this. It should be 273, at least on your test, and then you have your 3.0, and then, of course, the 3.0 liters divided by 290 Kelvin. That will be your V2 divided by 273 Kelvin, and you're multiplying it by 273 Kelvin. Okay, so if you cancel that, okay, you multiply the 273, and really the difference is that I put 2.0 and they put 3.0. So it's the same thing. You multiply these two, you divide it by 290, it should give you the correct answer. If I put 2.0 times 273 divided by 290K, that will give you the 1.88. Okay, so again, really they just go way based on, because this division, they multiplied it, right? That's the opposite. Okay, and I could have showed you this way, really. I think it might be even shorter, but you know, I just so used to the cross multiplication. Okay, so let's go ahead and go to the next one. Okay, so again, this is only from the test. This is from the test. Okay, at least for this problem. Okay, let's look at number 14. Calculate the decrease in temperature. Okay, so again, it's V1 T1 equals V2 equals T2. Okay. And what I'm going to do is I'm going to go ahead and set it up like the test, since I want to make sure I don't get you all confused with the cross multiply, but I hope you understand the cross multiplying, especially if you're going to physics. It's important to understand, especially if you don't understand how to the rules between basically on manipulation. So what I'm going to do is I'm really just make it just like the exam on this next one, because I don't want to confuse you like here. Okay, so calculate the decrease in temperature when 7.0 liters at 20 degrees Celsius. Now, you know that we don't want degrees Celsius. We need it in Kelvin. So this 20 degrees Celsius, we gotta do this. We gotta put it in the equation. So 20 degrees Celsius plus 273, that should equal to 293 Kelvin. Okay, right? Because that equals to Kelvin. Okay, so anyways, so the initial volume is that. So V1 equals 7.00 liters. Your temperature 1 is at 293 Kelvin. And my second volume is at 4.00 liters. And my second temperature is at I don't know. That's my unknown. Okay. Okay. So now let's go to the next one. So volume 1 will be 7.00 liters divided by the 293 Kelvin, which equals to volume 2, which is 4.00 liters. And then the T2 is the one that it needs to be by itself. Okay, now I very much prefer cross multiplication, but this is the setup for your exam. At least that's how they put it in there. Okay, this should be the setup. Okay, again, I just changed maybe the liters. Instead of 6.0, I put, I think, 7.0. Yeah, 7.00, and instead of 7.00, I think I put 6.00. Okay, that's the only thing I changed. Everything else stays the same. Okay, so let's go ahead and, yeah, let's just do the cross multiplication. Okay, so 7.00, let's just set it up, 7.00 liters. And I'm going to put parentheses because we're multiplying it to T2 equals, and then again, it will be 4.00 liters. And then we're going to multiply it by 293 Kelvin. We want the T2 by itself, right? Because we want to solve for that. So we want to move that number with the other numbers. So you do the opposites. You're multiplying. You do, okay, you divide. You do the opposite, it's division. So you do the same thing to the other side. Remember, you're moving that same with the other numbers. So you cancel that because it's just 1, and it's T2 equals, and it will be 4.00. Okay, so it is, when you multiply those two, you get 1172 liters times Kelvin, divided by 7.00, divided by 7.00. That should give you 167 Kelvin as a temperature. Okay, so again, you would have a different number, but that's how you do it. Just cross multiply. I think it's a lot easier since you're so used to knowing how you just divide it by itself and then do the same thing to the other side. Okay, and once you multiply these two and divide it by that, that should give you the answer. So your answer should be a little different, but I did wanted to emphasize on the setup, at least on your exam. Okay. Other than that, pretty much that's it, you guys. Bye.